This week we'll be looking at a very important formula called the quadratic formula. And this is used very often when you're dealing with quadratics, and you'll see it in your future math courses for sure. So let's start off with kind of a quick example here. So warm up. What are the x-intercepts of y equals x squared plus 2x minus 5? All right, so that's a pretty standard parabola. It's asking us for x-intercepts, so the first thing we would think about would probably be factored form. Okay, let's switch it into factored form, and now we know our x-intercepts. All right, so let's try and switch this into factored form. There's no a value, so I think we would just look for numbers that multiply to -5, the last number, and add to the middle number, 2. Right, basic factoring with no a value, numbers that multiply to the last one, add to the middle one. All right, numbers that add to -5. -5 and 1, 5 and -1. And that's all of them that I can think of. There aren't any other nice numbers. I want to choose the ones that add to 2. Ooh, uh-oh. Neither of those add to 2. So hold on, nothing works here. I actually can't factor this. I'm looking for numbers that multiply to -5 and add to 2, and there aren't any. Or maybe there are numbers, but they would have to be some sort of decimal number. So that's the problem here, right? Maybe there are some other numbers, but I can't really start to guess them because there's so many possible decimal numbers that would also multiply to -5. In fact, there's an infinite number of possible values here that could multiply to -5. So how could I possibly go through and check every single decimal value for these numbers? Well, let's see here. If nothing works, maybe there aren't any x-intercepts. Let's plug this into Desmos. X squared plus 2x minus 5. Ooh, hold on. No, there are x-intercepts. So, okay. Even though I couldn't factor it, there are still x-intercepts, but they are some sort of decimal number. Do these numbers multiply to -5? Yep. Do they add to +2? Or the inverse of those numbers? Yeah, but how could I could never guess these numbers. So that's where this quadratic formula comes in. So when you get in a scenario where you want to find the x-intercepts, but you can't factor, sometimes the factoring, it's some decimal number that you can't guess. In that scenario, you use the quadratic formula. All right, so quadratic formula, because we're dealing with x-intercepts, we always say x1, 2, because there might be 2 x-intercepts. So there could be 2 possible solutions. All right, that's the quadratic formula. So x equals -b plus or minus the square root of b squared minus 4ac divided by 2a. Okay, so this is quite a mess. I'm not going to show you the derivation of that formula, where that formula comes from. If you want to, you can look it up. So you would just look up derivation of quadratic formula. It's quite messy to follow along with, but it is possible to follow along with it. Really, right now, I'm just worried about learning how to use it. So in this formula, the A, B, and C, because that's all that there is here, A, B, and C, those just match up with the coefficients. So the numbers that are in front of the x squared, in front of the x term, and in front of the number term. So in this case, my A would be a 1, because it's a 1x squared. My B would be a +2, and my C would be a -5. So even though this formula is a bit of a mess, all you do is you figure out what is your A, B, and C values from your equation in standard form. And you take those A, B, and C values, plug them in for A, B, and C down here, and then simplify that formula. And you'll notice that this formula has a plus and a minus in it. So that means you actually need to solve it twice. You need to solve it with the plus to get one answer, one x-intercept, and with the negative to get your second x-intercept, your second answer. So that's how the two answers appear, one from the plus and one from the minus. All right, let's do some examples. All right, so first one, y equals 2x squared plus 4x minus 6, and it's just asking me what are the x-intercepts. Could I factor this one? Maybe, right? I could probably pull out a 2 and then try and factor. But hey, if I want to know the x-intercepts, I could instead just go right to my quadratic formula. It might be a scenario where I actually can't factor. I don't really know until I try. So hey, let's just solve it with quadratic formula this time. So first thing, let's define my a, b, and c. So a is 2, b is b is 4, c is negative 6. And it always takes the sign with it, right? So positive 2, positive 4, negative 6. At this point, we're ready to plug it into our quadratic formula. And this is where it gets a little bit messy, right? But we're just going to copy that formula down, x1 and 2, and then replace each variable with the ones that are here. So negative b becomes negative 4 plus or minus the square root of b squared becomes 4 squared. This b I always put brackets around just because when you start putting in a negative, it gets a bit messy. So in this case, 4 squared for b squared. Minus 4, that's just part of the equation. Times a, which is a 2. Times c, which is a negative 6. Divided by 2 times a, which is a 2. So, okay, it's a huge mess, but all I've done, copied that down, replaced b with 4, a with 2, c with negative 6. All right, so all we need to do now is simplify this equation. There's only numbers on this side. All right, so when I'm simplifying, I always start inside of the square root. And because of BEDMAS, I'm always doing my exponent first, and then my multiplying, and I leave that, that subtraction to the end. So let's see what we got here. So negative 4, plus or minus, starting inside here. 4 squared is 16. Negative 4 times 2 times negative 6 is positive 48. So I went plus 48. That's from the two negatives, right? Negative, negative, plus 48. Divided by 2 times 2 is 4. All right, so that's looking a little bit better. Let's continue simplifying inside the square root. I always simplify that first. Okay, negative 4 plus or minus 16 plus 48 is 64 over 4. Now this one, we can actually do the square root here. Square root of 64 is 8. So that's nice. This one seems to be working out nicely. And at this point, we can't really simplify any further until we deal with this plus and minus. So once you get to this state here where you've simplified really as far as you can go, now you split off into two answers. One answer will use the plus, one answer will use the negative. Okay, so first answer we're going to split off here. We're going to use the plus. So I'll rewrite my equation with only the plus this time. So negative 4 plus 8 over 4. And we can solve that one now. So that would give me a 4 over 4, which would be 1. So that's one of the x-intercepts. That's one answer. Now the second answer, I'll split off over here. This one will use the minus instead. So negative 4 minus 8 over 4. That gives me a negative 12 over 4, which is negative 3. That's my other x-intercept, and that's it. Those are the two x-intercepts. I'm done. So you'll notice how that plus minus split us off into the two answers. Now we can double check this using Desmos if we want. Let's see here. So 2x squared plus 4x minus 6. So there's our parabola. It is opening upwards, and it looks like it has an x-intercept at 1 and at -3. Good, so that matches up. X-intercept at 1 and -3. So quadratic formula, if you use it, it gives you the x-intercepts of the parabola. You can use it for any quadratic equation in standard form. All right, let's try one more here. So if you want to, you can try this one ahead of time on your own. So if you wanted to, you could pause the video and then check back here in a minute. All right, hopefully you had a chance to try that one out. Let's go through the answer now. So first thing, find the x-intercepts. I start by labeling my A. A is 2. B is -4. And C is -7. Always keep that sign in front. At this point, it's really just a matter of plugging A, B, and C into this quadratic formula. And you'll always be given that formula. I don't expect you to memorize it. But once you do a bunch of these questions, you end up remembering it anyways. All right, rewrite my formula. X, 1 and 2, right, for the two answers, equals -b, so that's -4, turns into a +4, plus or minus the square root. B squared becomes -4 squared. You'll notice I put brackets just to keep track of it. -4, part of the equation. A is a 2 times C, which is a -7, divided by 2 times A, which is a 2. So just be really careful of signs and make sure that you're plugging everything into the right spot on this step. And at this point, we are ready to simplify. So I always start inside of the square root. So 4 plus or minus -4 squared turns into a 16. Negative, negative, positive 16. -4 times 2 times -7 gives me positive 56, right? Negative, negative, positive. Divided by 2 times 2 is 4. Okay, keep going inside the square root. 4 plus or minus root 72 over 4. Right, in this case, square root 72, I don't think that one's nice. It's a little bit of a messy number, right? So I can turn it into a decimal number either now or later on. I think I turn it into a decimal later on here. So at this point, that's really as far as I could go. So let's split it into our two answers here. So first answer with the plus. 4 plus root 72 over 4. And we can keep going and solve that one. So I'll need a calculator here, right? Root 72 is a bit of a mess this time, right? So 4 plus square root of 72, and then divide by 4 comes out to 3.1. Next answer, doing the subtraction. 4 minus root 72 over 4. Once again, you'll need the calculator with that square root there. So 4 minus root 72, then divide by 4, negative 1.1. And those are my two x-intercepts. So at this point, I'm done. Now notice in the last question, the x-intercepts were pretty nice. Maybe you could have figured them out. Maybe you could have factored. But in this case, these x-intercepts are pretty messy, right? To be able to factor this guy, you probably wouldn't have been able to guess these values, right, in terms of the adding and multiplying. So you really needed the quadratic formula for this one. And we could check this one on Desmos as well. So 2x squared minus 4x minus 7. And that gives us back x-intercepts of 3.1 and negative 1.1. Now you'll notice I rounded this answer off, right? If you kept square root 72, if you kept a bunch of decimals, you would have had more of the decimal places here. I just rounded off for my answer. So this also allows you to solve ones that don't have exact answers, right? All right, one last question. All right, so for this guy, you're not given the quadratic formula. You're just given some sort of expression, right? But you can use it to solve these ones as well. All you need to do is move everything to one side of the equation. Right? So in this case, if you can move it into standard form, which is x squared term, x term, and number, all on the same side, then you can use your quadratic formula. So in this scenario, all I would do is I would start by moving that 4 over, using opposite operations, just to get it into standard form. So in this case, I'll add, subtracting, so I will add 4 on both sides. And that leaves me with x squared minus 3x plus 4 equals 0, since that's disappeared. And at this point, if I wanted to solve this equation, solving the equation equal to 0, that's like a y equal to 0. That's the same as finding your x-intercepts. So you can also use the quadratic formula to solve a quadratic if it's equal to 0. Because being equal to 0 is no different than finding an x-intercept. So at this point, my a value, there isn't one there, so it's like a 1x squared, right? So 1. My b value is a negative 3. My c value is a 4. And once again, plug that into quadratic formula. All right, so x1 or 2 equals minus b minus negative 3 is positive 3, plus or minus the square root of b squared, so negative 3 squared, minus 4 times a, which is a 1, times c, which is a 4, divided by 2 times a, which is a 1. So if you're not sure, you can kind of pause and just make sure that you've plugged everything in the same way as me here. And at this point, we just need to simplify. All right, so when I'm simplifying, I always start inside of the square root. So in this case, 3 plus or minus negative 3 squared gives me positive 9. Negative 4 times 1 times 4 gives me negative 16 over 2. Still simplifying inside of the square root there. 3 plus or minus root negative 7, right? 9 minus 16 is negative 7 over 2. And, oh, hold on here. Square root of negative 7? Can you have a negative in a square root? No. Whoa, hold on. So as soon as you see a negative in a square root, that's a problem. You are not allowed to do the square root of a negative number. Right? Two of the same numbers that multiply negative 7, well, if they're both positive, you get a positive. And if they're both negative, you'd get a positive. So that's why you're never allowed to have a negative inside of a square root. So as soon as you run into that scenario, you're going to stop and you're going to say, hold on, there's no solution. I can't answer this question. There's no solution because I can't solve this. That means there's no x-intercepts. And you're done. Remember, you can have a parabola that has no x-intercepts. And that's what you would see in the quadratic formula when you get that scenario. Let's double check this guy on Desmos. So we had x squared minus 3x plus 4. And sure enough, that parabola, it's a valid parabola, but it has no x-intercepts. Right? It doesn't go low enough to hit the x-axis. And in that scenario, you would just get a negative inside your square root.